9.4 Implicit differentiations. From the previous lesson, we have learned on how to differentiate the function with y as subject, so we can differentiate explicitly. But sometimes we have to deal with a function such as 2y cubed minus y squared equals to this. And from here, it is not easy to state y as the subject. So to find the derivative for this type of function, we need to use implicit differentiation. If I have d dx of x squared, we need to use power rule because we have power here. So we bring down the power, copy the function inside the bracket, and then we reduce the power by 1. And we need to differentiate the function inside the bracket, which is for this case is x. And d dx of x is 1. So that is why we will get 2x. But if I have d dx of y squared, so bring down y, the power, copy y, reduce the power by 1, so we have 1. And then we differentiate the function with respect to x. The function is y. And d dx of y is not 1. Therefore, the answer is 2y dy dx. Or in other words, if we have y, we will have dy dx. Next, we go to example. Example 21 on page 18. Y cubed plus 6x equals x squared. So we need to differentiate term by term. For y cubed, derivative of y cubed will be 3, bring down the power, copy the function, and then reduce the power by 1. And next, we need to differentiate the function here. So, differentiate dy with respect to x plus differentiate 6x is 6 and equals differentiate x squared is 2x. So we have 3y squared dy dx equals 2x minus 6. Or dy dx equals 2x minus 6 over 3y squared. Next, we go to example 22 on page 19. Given the equation, find dy dx and d squared y dx squared. So this is the second order derivative. At a point 1, 3, 1 is the value for x and y is 3. The first, 3x squared plus 4y squared equals 15xy minus 6. 3x squared, we can differentiate explicitly, directly. And for this one, we have y. So implicitly. And here we have 15, the coefficient, x times y. So we have times y in multiplication form. So we need to use product rule. So for product rule here, what is your u? And what is your v? So u is x and v is y. U prime is 1 and v prime is, differentiate y is dy dx. So now we differentiate all the terms. We have 6x plus, okay, bring the power down, 8y power of 1. And then differentiate y, we will get dy dx equals 15, the coefficient. Next, use the product rule formula. So we have y times 1 and then plus x times dy dx. So we try to simplify. 6x plus 8y dy dx equals 15y plus 15x dy dx. Okay, then from here we collect dy dx on the left. So 8y dy dx minus 15x dy dx, and write the other terms on the right. 15y minus 6x. Therefore, dy dx equals 15y minus 6x over 8y minus 15x. And at the point 1, 3, at the point 1, 3, so dy dx equals 15 times 3 minus 6 times 1 over 8 times 3 minus 15 times 1. So the answer for dy dx is 13 over 3. Okay, next part is to find the second order derivative. For second order derivative, okay, we need to differentiate dy dx one more time. And dy dx here in division form. So we need to use quotient rule. So for second order, we use quotient rule. We have dy dx equals 15y minus 6x over 8y minus 15x. So from here, u is 15y minus 6x and v is 8y minus 15x. U prime equals 15 dy dx minus 6 and v prime equals 8 dy dx minus 15. So the second order derivative equals, okay, we use the quotient rule formula. So we have y minus 15x times 15 dy dx minus 6 and minus 15y minus 6x times 8 dy dx minus 15 over v squared, and v squared is 8y minus 15x squared. And then at the point 1, 3, the second order will be 8 times 3 minus 15 times 1 times 15 dy dx, and dy dx is 13 over 3 minus 6 minus 15 times 3 minus 6 times 1 times 8 times 13 over 3 minus 15, and divide by 8 times 3 minus 15 times 1 and square. And if you try to calculate using your calculator, you will get the answer is negative 236 divided by 81. Okay, now we go to the next example, number 23. Given x times y is sine 3x, x times y in multiplication form. So we will use product rule. And you want to show something up to second order derivative, meaning that we need to differentiate 2 times. So for product rule, we have u equals x, v equals y. U prime is 1 and v prime is dy dx. So now the derivative becomes y times 1 plus x times dy dx equals derivative of sine 3x is, differentiate sine is cos. So cos, angle remains cos 3x, and differentiate the angle, differentiate 3x. So we have y plus x dy dx equals 3 cos 3x. And then we need to differentiate one more time. So differentiate y, we will get dy dx. Differentiate x dy dx. For x dy dx, here we have x, we have dy dx. So we need to use product rule. So u is x, v is dy dx. U prime is 1 and v prime will be d squared y over dx squared. And here, we continue here. Derivative of y is dy dx plus Derivative of x dy dx will be dy dx times 1 plus x times d squared y dx squared equals 3 is the coefficient. We need to differentiate cos 3x. Differentiate cos is negative sign. The angle is 3x. Next, we need to differentiate the angle. And the answer is 3. So from here, we have 2 dy dx plus x d squared y dx squared equals negative 9 sine 3x. And if you notice here, we have 2 dy dx. Okay, we got the same term already. And next, x d squared y dx squared. But here we have negative 9 sine 3x. And here we have 9xy. Okay, so we need to deal with this term. And from the original function, we know that xy is sine 3x. So sine 3x is xy. Therefore, we can write as negative 9 xy. Okay, so we have x d squared y dx squared plus 2 dy dx plus 9 xy equals 0.